Hello and welcome. Machine learning operations or MLOps is considered one of the hottest topics in the ML world nowadays. And as more and more organizations are moving from piloting to productionizing their ML models, you might be thinking what MLOps should look like for your team or your organization. If that's the case, you are in the right session as we will explore how you can use Amazon SageMaker to scale MLOps across your organization. My name is Romina Sharifpour and I'm a machine learning specialist solution architect at AWS. I work with customers and help them to conceptualize, build, and operationalize their ML solutions. Today, I'm honored to be joined by the head of AI/ML from Carsales, Gus Nalvan. In this session, we'll start by a quick introduction to MLOps. We then learn about MLOps using Amazon SageMaker and how it can provide you flexibility and promote collaborations between various team members. Finally, we will hear from Gus sharing with us on how Carsales is scaling up their AI using Amazon SageMaker ecosystem. Please note that this is a level 400 session and assumes prior knowledge in MLOps space. Okay, let's dive right in. A survey conducted by Algorithma in 2021 indicated that the total timeline required to deploy a model is significant. Only 11% of organizations could deploy a model to production within a week, and that 64% forming the majority are taking a month or longer. But what makes machine learning deployment so different compared to the software engineering, where we see some organizations deploy new software in a matter of just a few minutes? There are a number of challenges that we see with the machine learning, and the one most emphasized is that ML code is only a small fraction of ML system as shown in here. This is taken from a paper published by Google in 2015 that elaborates the hidden technical depth in machine learning systems. As you can see, several of these factors are related to system designs and infrastructure that sits around the ML code that can be vast and complex, requiring a specific engineering effort and processes. One other unique challenge in productionizing machine learning is the independency of data and code that requires us to design processes around the data pipeline as well as validating the data quality. We also hear about what it takes to break across team silos and get multiple personas such as data engineers, data scientists, machine learning engineers, and developers to work efficiently together. That often adds to the complexity of MLOps. Machine learning systems also require us to manage experimentation that is involved in building the ML models. That leads us to a new set of considerations around version control, tracking, and automation. We also need to constantly ensure of the quality of the data and models, which can be a difficult task. While we can put in place automated tests that can help us improve the overall quality of the models, we still need to account for detecting the bias in our data, ensuring the fairness of our model, and sometimes involving the human in the loop. Finally, we will need to think about a secure and performant deployment strategy, as well as tests in place to monitor the model in production and detect any data or concept drift. To be able to successfully navigate through these challenges, MLOps often requires a combination of people, processes, and technology working hands in hands together that makes it quite a broad topic. So, focusing on the technology pillar, for this session, let's move past building solely automated machine learning workflows and see what it takes to incorporate the core CI/CD practices such as the version control, continuous integration, and the delivery, leveraging Amazon SageMaker pipelines. Amazon SageMaker Pipelines is a purpose-built, easy-to-use, continuous integration and continuous delivery service for machine learning. In a broader sense, SageMaker Pipeline consists of three components. One that can help us create automated workflows easily for various ML steps, that is the pipeline or workflow component. The second, the model registry, is the tool that helps us manage various models and their versions. And the third is the project that allows us to incorporate the CI/CD practices when designing these workflows. The pipeline component allows you to build and create automated workflows using Python SDK. The focus of this component is really on orchestrating the tasks and steps that are required for your model building activities. Typically, we see these steps to include data preparations, model training, tuning, evaluation, and potentially registering that model. The second component is the model registry. Many customers have hundreds of workflows with different versions of those models. So you need a mechanism to keep track of all these models. SageMaker Model Registry, which is a managed tool, helps you centrally manage model metadata for model versions. The final component is SageMaker Projects that incorporates the CI/CD practices such as automated triggers, source, and version control. If you go to SageMaker Studio to create a project, you can see that there are a number of pre-built templates available for most common machine learning workflows. There are templates available that cover the end-to-end or only a part of the ML workflow. There are also templates that integrate with the third-party developer tools such as GitHub or Jenkins, so that it provides flexibility for customers that may not use SageMaker end-to-end. So, what are these MLOps projects and how are they created? These pre-configured projects are a portfolio of products created in AWS Service Catalog. To be more specific, these projects are CloudFormation templates that allow you to set up and configure your CI/CD pipelines through infrastructure and configuration as code. This means that you have the full flexibility to use one of the pre-configured templates or bring your own to the SageMaker Studio. Now, let's take a closer look at what resources are put together as part of these templates. As we can see, this template covers a typical end-to-end workflow that includes the model build phase as well as the model deployment phase. You can see there are two pipelines created in AWS Code Pipeline. One is the model build pipeline that automatically triggers and runs the workflow end-to-end whenever a new commit is made to the source code for the model build stage. The other pipeline is in charge of the model deployment that automatically triggers whenever a new model version is added to the model registry and the status is marked as approved. The codes and configuration files associated with these two pipelines I just mentioned about exist in two repositories in AWS Code Commit. These repositories use code build and CloudFormation to execute the build pipeline automatically and create model endpoints for deployment. Other resources include an Amazon S3 bucket that is created for model artifacts generated from the pipeline, and also two SageMaker endpoints that are deployed after a model is registered and approved. These are a lot of components working together. But using SageMaker projects, you don't have to worry about putting all these components together yourself from the scratch. You can customize these templates to your need that help you move fast in getting the models into production, coupled with CI/CD best practices. Like I mentioned before, a team of data scientists and developers can use SageMaker pre-built projects or bring their own custom templates. In this example, we have created a custom template that includes three pipelines. One that is dedicated to wrangling and ingesting process features into SageMaker feature store. The second, the build pipeline, takes care of model training and also incorporates a step to conduct data bias analysis and creating model monitoring baseline for data drift check. The third pipeline is the serving pipeline that includes a real-time endpoint as well as a batch inference workflow. So it is easy to see that you have the full visibility and flexibility to build more complex orchestrations with multiple steps that allows many different teams inside your organization to experiment, innovate, and integrate faster. One other aspect to successfully scale MLOps is about enabling various personas with different skill sets and smooth out how these team members can work together most effectively. This can be in the form of removing the complex, unfamiliar DevOps part from the data scientist workload and in turn allowing ML engineers taking care of the infrastructure and the engineering side. But at the same time, enabling these personas to continue and build on each other's work. To facilitate this, you can define multiple different roles that each provides a user with well-defined access to relevant resources. For example, you can create a ML engineer role assigned to your ML engineers who are responsible for provisioning the project templates that creates the CI/CD pipeline, model registry, and other resources. Data scientist role can be assigned to your data science team, responsible for creating the ML pipeline that ends with a trained model registered to the model group, which will trigger and run the deployment pipeline automatically without having your data scientists worrying about managing that. You might also define an approver role, such as your lead data scientist, who is responsible for testing and approving the models into production. This will not only allow for best CI/CD practices, but also for various team members to work together effectively with well-defined responsibilities and access level. Now, I'd like to invite Gus to tell us about his story at Carsales.
Thanks, Romina, for the awesome SageMaker ecosystem introduction. My name is Gus, and I lead the AI and ML initiative at Carsales. From here on, I'm going to show you how we use SageMaker ecosystem to scale up AI initiatives at Carsales. But before I start, here is a little bit about Carsales. We own a portal which facilitates car buying and selling for both private and dealer. We have around 160,000 Australian cars, with 3,000 cars roughly coming in every day. And apart from cars, we also have bikes, boats, trucks, caravan, etc. And we have presence in USA, South America, and South Korea. We have built and productionized many AI tech for years. For example, Cyclops car recognition, which is able to identify car, make, model, body down to the trim level from a single photo. Mystic is a regio detection model which looks for the regio plate from photos uploaded by our seller and blurs them to protect their privacy. We have a lot other AI models, such as automatic ads approval, recommendation, etc. And just to give you a sense of scale, a lot of our AI model, such as Cyclops and Mystic, is processing millions of photos daily in real time. Since 2016, our AI team has been the one responsible to build this AI tech end-to-end. At experimentation, we conduct data exploration, model building and evaluation, followed by productionization step to build continuous training pipeline to regularly train the model with the fresh data and to deploy the model as a service to be finally consumed by the requesting development team. In 2018, a new data science team is formed, which enable the second workflow, where they conduct the experiment and the AI team help to productionize their model. And as the year progressed, we realized that the demand in building AI tech is rapidly increasing as we want to be a more data-driven organization. And this causes an issue, as both data science and AI team are small, which become the bottleneck. We need to solve this problem without hiring hundreds of more data scientists and ML engineers, which won't be cost-effective. The plan is, in 2022, we want to enable 2 new workflows. With workflow number 3, any software development team can pair up with a data science team to help productionize their model. And with workflow number 4, any software development team can build the AI tech from end to end, from experimentation to production. And as we have a lot of software developers, this strategy will give us the scale that we want. So basically, we are turning our software developers into a citizen data scientist and an ML engineer, which brings in 2 challenges. How do we democratize the data science and ML engineering skills across our development teams? Apart from the bottleneck, there is also another problem that we would like to solve. Our data scientists mainly perform their experimentation locally on their laptop, as the current process does not allow them to easily experiment using the cloud computing, due to the reliance to a limited resource of DevOps time for provisioning. So let's sum it up. These are the requirements or challenges that we need to solve in order to achieve the scalability that we wanted. And most importantly, we want to do this cost effectively. And because we are greedy, we added 2 more requirements: a flexible model deployment and a model reusability across teams, which I will elaborate more in the later section. The solution which helped to achieve this scalable strategy is SCI8, which stands for Carsales Intelligence Academy. It's a thin-layer ML platform that we built on top of Metaflow and SageMaker. SCI8 consists of 2 distinct components: an orchestration tools built using Metaflow, which allow us to build a continuous model training pipeline. You can also use SageMaker model training pipeline to build the orchestration tools, as Romina has shown you earlier, if it fits your process better. And this is the great flexibility of SageMaker ecosystem, which offers various components which can be used independently or together as a whole. Our continuous training pipeline pushed the model to the deployment module to be deployed for inference serving, which was built on top of SageMaker. So, how does the continuous model training looks like in SCI8? Let's take a look at this common example of what an ML model training looks like. It consists of a few steps, starting with data extraction, transformation, model building, and ends with model deployment. With Metaflow, the whole process can be written as a flow, which is just a standard Python code, where each step is represented as a function with a step decorator. And to chain steps together, at the end of a step, you simply call self.next with the name of the step you want to execute next. A flow can be run locally, which is convenient during development and debugging. And it can also be run in hybrid mode, where you can choose which step you want to run in the cloud by simply adding a batch decorator, which will be executed automatically on AWS batch within seconds, removing the need to create and wait for the Jira tickets to DevOps to be actioned. So, our experimentation at scale requirement is ticked. To enable continuous model training, which require a scheduled and periodic training to execute in the cloud automatically, Metaflow will deploy your flow as a scheduled AWS step function. Next, how do we upskill our software developer with data science skills to give them ability to build AI model just like a normal data scientist? In order to answer this question, let's revisit our architecture diagram. If you recall that the continuous model training is simply just a Python script, it is entirely up to you how you are going to build the model, whether to use TensorFlow, PyTorch, sklearn, or SageMaker built-in algorithms via Python SDK. A SageMaker built-in algorithms is a collection of algorithms such as random cut forest, sequence-to-sequence, XGBoost, image classification, etc., which can be used to solve different types of problems. And they are super easy to use, as all you need to do is to prepare the required training set in the S3 bucket and format it to their requirement. With one line of code, you execute the training, and that's it. Your model is now built. Any software developer can do this without the need to know how to build those algorithms. Currently, about 70% of ML problems can easily be solved using this high-level built-in algorithms, and this number is increasing over time. Leaving the 30% which require a custom-built model done by our data scientists. It's a trifecta win as our data scientist loves hard challenge, and our software developer get to learn ML, and the business scales AI production cost effectively. So, democratization of data science skill is now ticked. Back to the architecture diagram. Now let's take a look at the deployment process. CIA orchestration layer produces a SageMaker model at the end of the training process. Deploying them for real-time inference using SageMaker Python SDK can be done with just one line of code. You choose the number and type of instance to serve this model, and no machine learning engineering skill is needed at all here. No doubt any software developer can do this job. And with that, democratizing ML engineering skill requirement is ticked. What does a flexible model deployment mean? And what problem does it really solve? Our previous ML serving platform only support real-time inference using an ECS cluster task, which is also called by a batch processing job, which does not really need a quick response. It causes a problem with ECS autoscaling as it sends a large number of inference requests in a short time burst, which is impacting the response time of other applications which really need a quick real-time response. And this is solved by replacing our model deployment with SageMaker, where you can choose a different inference types, how you are going to serve the model. Will it be a real-time endpoint when it has to respond within a fraction of a second? Or will it be batch, where an application will call your model a few times a day to perform a large number of inference, but an instance response is not required? Or serverless, when your model receives an infrequent call, but require a quick response. Serverless is a very cost-effective compared to a real-time endpoint, which has to be provisioned for 24/7. And with this flexibility, the requirement of flexible model deployment is ticked. Having a goal for many teams to build their AI model end-to-end raises a new challenge. How do we avoid one team building a model which already built by others? Hence, we need to allow model reusability and discoverability across teams. And this is solved by using SageMaker Model Registry. At the end of the training process, the model is saved first into a centralized model registry before we deploy it for inference, which is done by a few lines of code using SageMaker Python SDK. It lets you define the instance type suitable for inference, approval status, and a description, which makes it easier for others to discover and find out more about this model. And using Amazon SageMaker Studio, any team can now browse models built by others to find the one they need before they deciding to build one themselves. You can drill down to a model and see their description, the approval status. Was it rejected or approved and created by who and when, providing you with a full audit trails. And adding a new status update can also be done within the GUI. It is such a useful moderation tools, and I'm really keen to see more collaboration and communication tools being added here in the future. And furthermore, you can see the location of the container used to build this model, the S3 bucket where the model is stored, the training job, and most importantly, the S3 location of the training set, which is called input artifact, so that you can easily reproduce this model if needed. And once you find the suitable model, deploying them from the registry is as simple as a few lines of code. With this, model reusability across teams is ticked. I have now shown you how we overcome these challenges to scale up our AI cost effectively. We are still halfway through this journey, but we already start seeing the benefit of this strategy. Recently, one development team with zero data science and ML engineering skill built and deployed an image classification model in just 5 days with CIA. Previously, it took a team with ML engineering and data science knowledge 2 weeks to complete the same task. And this is just the beginning. Finally, I'd like to thank our awesome team who worked hard on this. And with that, I will pass the stage back to Romina to close the talk.
Wow, Thank you, Goose. Great stuff. So to wrap up the session, building MLOps capability is a journey, and it is really about culture and technology working together. So build a culture that allows for continuous nurturing and development over time. Start small and then build on that to create more complex workflows and processes. As discussed by Goose, SageMaker allows for flexibility to utilize only the capabilities that is suitable for your use case. For example, you might want to use only model registry without using the SageMaker projects, or if you'd like to define your own CI/CD framework using AWS or third-party tools. This can significantly reduce the cost of building an MLOps platform and allow you to democratize AI across your entire organization faster. Explore other capabilities that can help you address some specific requirements within your MLOps architecture, such as SageMaker Model Monitor or utilization of SageMaker Feature Store. If you want to create your own custom projects, use SageMaker provided templates to understand how to organize your code and resources and build on top of it. And finally, utilize automation and manage orchestrations where possible that can increase your deployment velocity, reduce efforts and costs in managing pipelines, and also help in bridging the gap between different roles within your team. To continue your cloud journey, please use these training resources. We really like to thank you for your time, and I look forward to hear about what you build next. We value your feedback to help us improve our session, so please remember to share your rating with us. Thank you.